statistical hypothesis. What is statistical hypothesis? Statistical hypothesis is a starting point of a research, right? So it depends upon what questions is there in your research, right? So basically, if you say what is hypothesis, hypothesis is nothing but a statement or a assumption, right? So hypothesis will be, you can say hypothesis will be a statement. It will be a statement or assumption. Now question comes, all statements are hypothesis? No, it is not possible. All statements are not hypothesis, because hypotheses generally have a property which is not limited to just a simple statement. First thing first, it depends upon your research question, right? What is your research question which you are looking? Now, based on your research question, you will be formulating your hypothesis, right? So, for example, in the class, I would ask whether there is a difference of height between girls and boys, right? So, what I do is I make group, right? I make group like girls and boys, and record their height in centimeter, right? Say suppose centimeter. Say one first is this is your serial number, right? So we have around 5 or 6 participants here. 1, 2, 3, 4, 5, right? See, this is 162, 157, 151, 142, 147, right? So boys is around 171, 140, 162, 178, 179 and 181, right? So obviously there is a difference between height of boys and girls. Generally, if you see in this data, you will see height of boys is generally more than that of girls. So how I say that? I can say only when I will compare the means of the data, right? Means of the data means I will sum this up, and so this is my mean, or if I write mean. Now you can see we have taken the height of girls and we are observing the height of, we have written the boys' height, right? And 5 of them I have chosen randomly and I have compared the mean. By simply seeing the mean, you can see girls' height is around average around 151.8 centimeter, and that of boys is 174.2 centimeter. So there is a difference of mean between this, right? So we can say that boys are generally taller than girls, right? Because we have compared the means, right? You see, what was my hypothesis? Height is influenced by gender or not, right? My first assumption or the starting point of my research is I want to answer whether height is influenced by sex or gender, male or female, right? So I have divided, I have taken randomly chosen 5 participants and I have compared them and found it to be different, right? We talk about hypothesis. Hypothesis is a statement which can be tested, right? It can have 2 answers, right? Like 2 answers, yes or no, right? So it will have, if you flip a coin, just like if you flip the coin, sorry I dropped it. This is so in a hypothesis we will have, if I flip a coin, I will have a head or a tail, right? I have a head over here. So like that, there is a possibility of yes or no, right? So when I formulate a hypothesis, it will have either yes or no as an answer, right? It is testable. hypothesis can be tested, and this assumption has to be tested and tested against the data which you are collecting, right? The data you are collecting will depend upon the research question you are looking upon, right? So day before yesterday we discussed about the growth of plant in different fertilizer treatment. We can tell whether fertilizer treatment affects the growth of plant. Plant growth of this pigeon pea again, then plant growth in this fertilizer treatment is so seemingly okay, and this is somewhat smaller, right? So what will be my hypothesis? My hypothesis will be whether amount of fertilizer influences the plant growth, right? This will have data collection. All of you know it will be assemblage of data, and this data can be tested, right? Tested against the mean values, right? So hypothesis generally is tested against the mean value. Mean value will be there. All data will have two properties. The properties are called as measures of central tendency, and all data will have measures of central tendency. Data have tendency to aggregate around the central value, right? Here in this case you can say it is mean, right? You are standing in a line, and how much of you? 1, 2, 3, 4, 5, 6, 7, 8 people are there, right? The fourth and fifth people, the in-between people, they will called as the median, right? Median is a positional average, right? So based on positional average, I can divide the data also, right? I can divide all of you in two different sets. For odd number is easy. If 5 people are standing, I have five markers with me, right? This will be my median. This will be the central value, will be the median value, right? So based on this positional average, I can divide my data set into 2 equal half. Similarly, for mean also I can divide my data set into half. Now we have seen the data to be different. The next question comes into my mind is whether they are different significantly or not. For that, a statistical statement should be true for 95% of the time, right? 95% if I am correct, then only I can say my data is correct or significantly different. So normally in statistical hypothesis, a normal distribution is followed. In a normal distribution, you will have a data like this, right? Data curve like this. It goes up to certain extent and then it comes down, right? And this region, the maximum data wherever it is possible, this is the 95%. You can say this is the 95% acceptance level. 95% level, right? So we have this is 95 level, and this is around 2.5%, right? And this is around 2.5% because we have to make up for 100%, right? So this is called the level of this is called level of acceptance, right? And this level, the negative part or the rightly skewed part, this will be the rejection level, right? So data falling on extreme left, or some data extreme data falling on extreme right will be rejected, right? So this will be this is what? This is a normal distribution curve. right? So here against this we have a value which is we are testing it against the mean value, right? The mean value we are testing against the mean value. How much each values deviate from the mean value. So most of them will fall within the level of acceptance, but some data, like if I am going for height, some people will be extremely taller, right? So extremely taller people will be on this side, or some people will be extremely short, they will be in this level, right? But more or less in the class itself, you will find the students to be here in this height group, right? So this is called 95% of acceptance level. Some data will not have a normal distribution, right? Some data can be like, you can say this data is like this is there, right? So this is you can say this is positively skewed data. Some data will be the other way around. It will be having a height over here and it goes down. So this is called positively skewed. And this is negatively skewed. So in this data, it is not possible to take average as a divider, right? We will use median. We will use median value. Right? In these cases, we will use median value, and such tests are called non-parametric tests. Non-parametric tests. Okay? When you are testing a hypothesis or statement using median value as a reference point, it is called non-parametric test. When you are testing a mean value for hypothesis test, this is called a parametric test. So remember, right? So when you are comparing this against the mean value, so this will be parametric test. Will be testable. It will have two possibilities, just like coin, positive or negative, right? Or head or a tail, right? So in that case, we have two hypotheses possible. When you are testing a hypothesis, hypothesis will be hypothesis for normal distribution there are two possibilities, right? There are two possibilities of means, right? What means? Mean have two possibilities. Population means are equal. Okay, population means are equal. Okay, and population means are not equal. Unequal, right? So this assumption, the hypothesis assumption is called null hypothesis. This is called H naught. Null. This is called null hypothesis, right? And this is called you can write H1 also or HA also. This is called alternative hypothesis. So in between what is there? Either their means are equal or not equal. In between what is there? This is called 95% confidence, 95% confidence interval. I write in short confidence interval, right? Whether at 95% confidence level you don't find any significant difference, then null hypothesis is true. At 95% confidence level, if there is a significant variation of means, then alternative hypothesis is true. Right? So this is all about null hypothesis and alternative hypothesis. These are the two types. This is just basic introduction, and we are doing t-test, ANOVA test, Fisher test, Z test. All different tests are possible using this null hypothesis. Understand well, this is the starting point of research. So that's it all about